What do you mean the point slope form, and how is this determined when given the following? Either given the Cartesian plane with x and y, and you're given a specific line, or you're given a table of values where you have not only the x and also you're given the y. Now, to address this, we need to determine the following. First step is to pick 2 points. We need that for sure, because in this case we are addressing points, and so picking 1 point here which we're going to address as p, and another point here which we're going to express as p naught, is kind of the same way definitely when you're looking at the specific table of values, which is what we have right here, where our first point usually is your p naught, and your p naught is going to be what is going to be addressed first, and any other point that comes after will be addressed as p. So in here we need to recognize that as our first step, and then our second step is to determine the coordinates of these points that are here. And the coordinate of your p naught in this case here is addressed as your x naught, y naught, and it is reflected on the table of values, which is x naught, y naught. Any other point that comes after or before your x naught, y naught in this case will be addressed as your p. In this case we're just going to go with x and y, and this is any one here and its corresponding y, so we're just going to put x and y right there. Now take note here that once we've achieved these 2 terms, which is in terms of picking the point, or 2 points specifically, and also finding out what the x and the y's are, in this case we have our p to be corresponding to our x and y, and we have our p naught to be corresponding to our x naught, y naught. We will then move on to the next step, which is to derive the difference between the 2 points. In this case, this is addressed as 1. We need to not only determine what the change in our y-axis relative to the line is, but in this case we have to do that as well for our x, and so by so doing we can see on the graph specifically that our change in y is as a result of our y naught, which is our initial point, minus our final point, which is for its y, and so we have our y1, or in this case we have our y minus our y naught, and this is reflected as well not only on the graph but also on the table of values. Whichever point you start off relative to the other point, not only for the x but their y's, is what we are going with. So for our y, it means that we are going from our y naught to our y, and that is shown not only on the specific graph right here as changing y, but also our changing y is found on the table of values right over here. And so we are going to do not only that for our y but also for their x, and so that means we're looking at our run, which is our change in x gotten from our initial x point, x naught, and other point which is our x right here for the point. And so this is shown right here as your x minus x naught, which is equal to our change in x, not only from our graph but also from our table, as we move from x naught to any of the x that is corresponding to its y. And so we have this addressed in this particular manner. Now our next step is to divide our changing y by our changing x, because that is the only way to address the other part, which is our slope. And so slope, we know, is how steep your line is, and specifically we are looking at our non-vertical lines. Non-vertical lines really gives us any slope, including zero slopes. However, vertical lines do give us an undefined slope. So in here we have this to be addressed in or on our graph in terms of this steepness, how it is fast going in terms of the relation. And this here is as a result of the division of our change in y by our change in x. So by dividing our changes, that results in m, and m is defined as the slope or the gradient. And this implies that yes, we do need to do the following: determine our change in y, which is our y minus our y naught divided by our x minus our x naught. And by so doing, we can move on to our final step, which is to rearrange this equation to make it look like a point slope form. And to do this, all we have to do is to perform our final step, which is to multiply both sides by our change in x, which is expressed as x minus x naught. And therefore we are going to have our new equation, which is y minus y naught equals to m all multiplied by our x minus x naught. This is our final equation, and this equation here implies that yes, this is true for any line that is a non-vertical line, and this is expressed as the point slope form of a non-vertical line, and this is highlighted right here on this graph. Take note here that interpreting this implies the following: this x here is any point on the line, and that point has its y, which is right here. Now when you have your x naught and your y naught, this is the given point usually. And so when you're given just one point and you have this slope, you can determine the y of a given x point on this line. There's some other cases where you're going to be given just 2 points and you'll be asked to determine what m is. By so doing, you can not only determine what the change in y is by the 2 points, but also the change in x, and that gives you your m. All you have to do in this case is, once you determine your m, you can then pick a point and make that to be its x and its y. And by so doing, you can also show that yes, this can be rearranged in a way that it will look like your generic formula, which is y equals mx plus b. I hope you found this really informative. Please let me know your thought about this. By that way, I'll talk to you soon. Stay smart as always and believe in yourselves.